So we yesterday dealt with the aspects of equations with distributing and adding like terms. Always keep in mind what your goal is in solving an equation. That's to isolate the variable. What does that mean? Get it all by itself on one side of the equal sign. Oftentimes you'll have both things added to the variable and things multiplied. You always move things added first. Do you technically have to do that? No. But does it avoid a lot of students getting the problems wrong? Yes. And now we have a situation where we're going to solve equations with variables on both sides. Variables on both sides. Every equation we've done so far, either the variables were on the left or the variables were on the right. Well, that's not always the case. Sometimes the variables are on both sides, and we have to care for that. So, as soon as possible, and there's no other way to say that, the way the original problem is, whether it's less complicated or more complicated, determines when it's possible. So that's why the best thing I can say is as soon as possible. And I'll show you some problems to begin to give you a feel of when it's possible. But as soon as possible, choose a side and move all variables to that side. But be careful, because if there are quantities to distribute them first. And so you'll see that. But here's the big thought you have to get in solving equations with variables on both sides. I have to choose a side and get all the variables on that side. And that has to happen before you move anything else to any other side. You don't want to move things added to the variable until you decide what side the variable's on. You don't want to move things multiplied times the variable until you decide what side the variable or the variables are on. All right, we're going to come back to A in a moment. We're going to do the problem first and then see if you can fill in the blank for A. So here's our first example. 8n minus 7 equals 4n plus 5. Now in this problem, there is no distributing. So we're really ready to choose a side. So we have to make a choice. Oh, Windows 7. So we have to make a choice. Are we choosing the left side of the equal sign or the right side? Do we want our n's on the left or do we want our n's on the right? Quite honestly, there's no wrong answer here. However, there is a better choice. So you can choose to move the 4n from the right and move it to the left, or you could choose to move the 8n from the left and move it to the right. It's your choice. One of them I feel is better than the other, and one of them gives you a higher probability of getting the problem correct. So though it doesn't really matter which way you go, in the sense of you can get it correct either way, you're better off choosing the best way. Okay, so first decision is, do we want the variables on the left or do we want the variables on the right? So make a choice. Just choose. On 3, I'm going to ask you to give me your choice. Everybody should either say left or right. All right, here we go. 1, 2, 3.
Left.
Okay, I heard a lot of lefts. I heard a few rights. Who are my left people? And who are my right people? Okay, so it was a little bit more than I thought on the right side. All right, so anybody on the left want to debate their cause why you want to go left? Aaron?
You want the variable first.
You want the variable first. Okay. So that's her debating of her reasoning why to put them on the left. How about person that wants it on the right, debate your cause? To debate your cause, listen, when you debate your cause, you're trying to convince the people on the other side to come to your side, right? So you want to explain it in a way that people will say, oh, okay, I'm going to choose your way. Brendan?
I like adding more than subtracting.
Okay, Brendan says he likes adding more than subtracting. All right, based on those two debates, anybody want to convert? Really? I wouldn't convert based on, because I have no clue what in the world either of those debates meant, all right? None of them helped me to determine anything. Some of you just want to change because you like to change. All right, here's basically the answer in a nutshell. Neither one, there's not an incorrect answer, but there's a better answer. On this one, we're going to choose the left. We're going to choose to move the variables to the left, and I'll show you why in a moment, okay? I'll show you why in a moment. So here's what we want to do then. We need to move the 4n to the other side, right? Now the next question is, don't say anything out loud. This is the key concept of the whole lesson. So think. If you can figure this out, you'll probably remember it the rest of your life. If I have to tell you the answer, you may remember it, you may not. But if you think of it and figure it out, you'll probably remember it the rest of your life. So how are we going to move that 4n to the other side? That's the question. All right? And I'm open for suggestions. Nia, what do you want to try? And by the way, you might as well try something, right? Because you can't get anywhere if you don't do anything, so try something. Nia, what do you want to do?
4n minus 4n, 8n minus 4n.
So you want to add negative 4n to both sides? Is that what you're saying? So you want to do like this, and like don't do anything yet. We're just taking possibilities. So that's what Nia wants to do. Anybody for that idea? Anybody agree with Nia? Is that a yes? You're agreeing? That's my question right now. Anybody agreeing with Nia? Okay, 3 people agree, 4 people, 5. Oh, we're getting like conversions all of a sudden. Okay, how many have a different way? Different. Julia, what do you want to do? Okay, so you want to put a +4 right there like that? You said after the 7. Did I not put it where you wanted it? Come on up here. Come on up here. You put it where you want it. There you go. That's okay. Go ahead. Okay. So you put a +4n, okay, after the 7. Okay. How many agree with Julia? Let's put a +4n after the 7. Just 1. Does anybody have anything else? Anybody have anything else? Edward.
You add the 4n to the 8n.
So you want to do like this. How many agree with Edward? Didn't you agree earlier with, are you changing? You're converting. Okay. We're getting conversions. Okay. Okay. Agreeing. All right. Put your hands down. Anybody have anything else? You just agreed with Julia. You can't have anything else. You had Julia's position. Okay. All right. So out of those 3 different ways, one of them was correct. One of them was correct. So the one that's showing is Edward's way. Julia's way, I can't go back that much, huh? Julia's way was like this. And then Nia's way was like this. All right? So you had Nia first, that's showing. So being that one's up there, how many now think that this is the way to go? Okay, and then the second way was like that. Oh, it won't do it. All right. Second way was like that. Who agrees with that? Not even the author. All right, that one's out. And then the last way was like that. Who agrees with that? All right. What in the world would allow a 4n to go from the right and all of a sudden stick on the left? What allows that to happen? Anybody know anything that would mathematically allow you to do that? Brendan?
You get rid of it on the other side.
How do you get rid of it? Like, are you doing some kind of hocus pocus, dominocus? I mean, what are you doing?
The same as when you do an added variable. When there's a multiplied one and an added one, it's like doing the same thing. And you
By
get
just
the-
sticking that on the other side? I've never done that maneuver ever.
You do it the negative 4n on that side too, and it cancels.
So I do this on this side and that on that side? Is that what you're saying? I've never done that. Have I?
It's not a plus on that side, it's negative also.
Oh, well, that's not what we're at. The question was that. That's what Edward said to do.
Oh,
All right. So hopefully I left enough time, and hopefully your brain is thinking enough, and hopefully now you're ready for the answer. But look, let's suppose that, I don't know what n equals on this equation. I don't really care yet. We'll figure it out in a minute. Let's just, for example, say the n equals a 3. Then the value of this would be a total of 12. If, for some reason, I wanted to move the 12 to the other side, how would I move it? Just say it if you know it. Add what? Tell me what to do. How would I move it?
negative 4n.
Don't give me the numbers. Add what? To what?
Both sides.
To both sides. Okay. So if I want to move the 4n, how do I move it? I add negative 4n to both sides. And we're not always going to put this. You can do now. We're ready to write your notes. This we can do. We're not always going to put this 0 here, but what's positive 4n and a negative 4n? What do you get?
4n.
No. 0. That's the whole point of what you're doing. That was 0. You still have the plus 5. And now our left side is 8n minus 4n is a 4n, and you still have the negative 7. Now again, we're not going to include that 0. I just put it in there now to make the points. And look, you better look and make sure that that's 0, otherwise you didn't move it. It's just like a number. You can move it to the other side. We're not trying, and thankfully nobody said multiply by the reciprocal, which was good. Because are we trying to split the 4 away from the n? No, we're trying to move the whole 4n. So now let's go back and fill in the blank. How are variables moved the other side? By adding their opposite to both sides. So we already know how to do this concept, and it shouldn't be any big deal. Now, does anybody know now why I chose the left side versus the right? Colby? Say again? Nope, but at least you're trying something. Emily? All right, no. Chloe? What would have been negative? Nope. Brendan?
It left the positive.
Left what positive?
The n.
The ends. And if we move the 8n to the other side, the ends would have been, they would have been negative. Look, here's the reality. Stop clicking. Don't write this in your notes. Now, either way would work, but look, if I move the 8n, don't I have to add a negative 8n to both sides? So look where we end up here. Negative 7, which I don't care about that. I can't control that negative 7. But look now, my ends are negative. Let me ask you this. What do you lose more points for on quizzes and tests than any other mistake? Your negatives, right? So when I can avoid having a negative variable, I'd rather avoid having a negative variable. Again, can you do it either way? You can do it either way. It's just safer, and I'm all about safer. All right, so that was my reasoning. The reason I chose left was that would give me a positive variable. Okay, let's finish it. We know how to finish it. Now we got to move the, say it if you know it, -7, right? The thing that's on the same side as the variable. Because now we have the variable on the left. So our next line is 4n equals 12. And we can do the shortcut, right? Divide both sides by 4. Final answer, n equals 3. And remember, you can always go back and check your answer when you're doing a quiz or test. You can go back and put 3 in for n on the left, put 3 in for n on the right, and see if the left side equals the right side. The left will be 24 minus 7. That's 17. The right will be 12 plus 5. That's 17. 17 equals 17. Voila! We did it. So look, these really aren't that hard. But you do have to remember to choose a side. And then remember, once your variables are on that side, move the stuff away from that side. Students try to move things before they establish a side, and that's where they get in trouble. All right, let's do another one. Second example. 6x plus 3 equals x. For some reason, students miss this. I would put a red asterisk on this one. I'm going to box it in later with my smiley faces. Because for some reason, students tend to miss this kind of problem. Okay, so again, we got to choose left or right. Which side will end up with a positive variable, left or right? Here we go, on 3, 1, 2, 3. Left. I either have to add a negative 6x to both sides or add a negative x to both sides. Adding a negative x to both sides ends up with positive. So I need somebody to tell me what the next line will be, someone that knows what the next line will be. Gabe? Daniel? Shh.
X.
Quiet, please. Do you know what it equals? You need to think about it. Why do I have an asterisk? Because students miss this, and you don't want to miss this. What is x minus x?
0.
It is not 1, it's 0. The same reason 4x minus 4x was 0. 4 of them minus 4 of them leaves you none of them. 1 of them minus 1 of them leaves you none of them. That's 0. So don't make that mistake. All right, finish it. Add a negative 3 to both sides, right? Now we have 5x equals negative 3. Somebody raise your hand and tell me how to do the last step here. Christina?
Reciprocal.
Tell me what to do.
Multiply both sides by 1 over 5.
Okay. So we can do the full multiply by the reciprocal, or we could have done the shortcut. Either way, it ends up the same way. Right? And x equals negative 3 on the top, 5 on the bottom, and negative 3/5, right? Now, those are a little bit harder to check because you have a fraction. But you could, but it's a little bit harder because you have a fraction. Okay, so be careful with this one. I don't know what it is, but students don't want to say that that equals 0. And you don't want to do that because that's going to mess you up if you don't put a 0 there. Okay? So be careful, be careful, be careful. I got to get rid of some of them so I can do the next problem. Okay? Can you do that, right? Don't you have a smiley face pen? That would be awesome. Invent it and make millions. All right. Okay, do you see the difference in C? C, we have to distribute. So we're not ready to pick a side yet. Let's distribute first, and then we'll pick a side. So we did this last night. The front is a 4y, right? And the next term is a, say it if you know it, negative 6, and then it equals 7y plus 5. All right, don't say anything yet. Now we're ready to pick a side. Do you agree? Okay. So on 3, I want you to tell me left or right. By the way, that way is left, and that way is right. All right? Left and right. Left and right. On 3, 1, 2, 3.
Right.
Right, again, I think is the best answer because it's going to get your variable to be positive. Okay, I'm going to pause the video, see if you can finish this one. Are you ready? All right, if you got an answer on 3, just say the answer. It's going to be y equals, and then just on 3 say the answer. Here we go. 1, 2, 3. All right, I heard a lot of the correct answer. Negative 11 thirds, right? So you should have ended up exactly where I did. Negative 6 equals 3y plus 5. Add a negative 5 to both sides. Right? Remember what side you're moving stuff away from, the side that the variable is on. Some of you get mixed up and you try to move the wrong stuff. Remember, you're isolating the variable. Move stuff away from the variable. That means move the 5, then move the 3, and voila, you are there. All right, next one. So let's do this one together. Somebody raise your hand. Tell me the first step on this one. And take a look. Everybody should be thinking, right, Omar? Everybody's thinking. Nathan, first step, what would you do? Were you thinking already? You just not sure what to do, or were you not thinking? Okay. First thing. Juliana, what do you think? And by the way, you could always guess, right? Try something. I really want to do one thing first. You could, but I really want to do one thing first. Kristen? All right, so she wants to, let me say it a little bit better way, add the like terms on the left-hand side. So let's add the like terms on the left-hand side. 4 of them, and a negative 1 of them leaves you 3 of them. Do you agree? Okay, now let's go ahead and choose our side. Right? Because that's the next step. So, class, left or right? Left. I would go left. Somebody raise your hand and tell me how to go left. Colby?
Take plus 3n. We'll take negative 3n, which is 4, and then add
Tell-
3n plus to both sides.
What do you want me to add to both sides?
3.
3n? Okay, I agree. And I would have just said add a positive 3n to both sides, right? He got there, which is fine. Not a problem. You're in the right place, Colby. Okay, somebody tell me what the next line, therefore, will be. Hannah?
6n plus 2 equals 6.
And hopefully you agree. 6n plus 2 equals 6. Somebody tell me what to do next. Edward?
Add the opposite.
Tell me what to add. Just tell me what to do.
Negative 2 to both sides.
All right, I'm going to add a negative 2 to both sides. I agree. Oops, I did the next line. 6n equals 4. All right, somebody tell me how to finish it. Allison? Let's divide both sides by 6. Good time to use the shortcut. Am I done? Does n equals 4/6?
No.
So what are we going to do to finish? Right, reduce. And that one you could probably do in your head, right, as a 2/3. Always reduce. Always reduce. The only time you don't reduce is when you're trying to get a common denominator so you can add things up, and then you still reduce at the end if you can. Believe it or not, Algebra 2 this morning. You know how many students missed homework problems because they didn't reduce fractions? I was shocked. It's Algebra 2. They left stuff unreduced. I don't know what they were thinking. It was stinking thinking. That's what it was. All right. Let's do another one. Okay. Are we ready to choose a side? No. So somebody tell me what to do first. Amber?
You have to distribute.
All right. So tell me how to do it. Tell me what I get when I distribute it.
When you distribute, you get 8x minus 2.
All right. So she did 8x correct and minus 2 correct. And we still have negative 5 plus 3x, right? Do you concur? So 2 times 4x is 8x. 2 times negative 1 is a negative 2. Somebody raise your hand and tell me what to do next. What's next? Hayden, you've been awful quiet. What do you want to do next?
3x from both sides.
Not yet. I mean, Why do you want to do the 3x? So maybe you're just doing it instead of stating it. So did you choose a side? Which side did you choose? Okay. So I should have asked it that way. So he's doing the right thing. It's just I wanted to get the choice first. All right. So he said add a negative 3x to both sides. All right. I agree. That's a good choice. Somebody tell me what the next line will be. Raph, you've been quiet. What's the next line?
Negative 5 equals 5x minus 2.
All right, and I hope you agree because Raph is correct. Negative 5 equals 5x minus 2. All right, what's next? Don't say it out loud. Luke, go for this one. What do you want to do next? I agree. So Luke's going to move that negative 2 by adding 2 to both sides. Somebody tell me what we get. What do we get? What do we get? Colby, what do we get?
Negative 3.
Equals
5x.
5x. All right, and then finish it. Go ahead and finish it. You finish it. I'll finish it up here while you finish it. But that's it, right? X equals negative 3/5. Voila, we are there. Pretty easy, right? Equations are not hard. Equations are not hard. Okay, how about something like this? So this is the grand finale, last example problem. I'm going to let you guys do it. I'm going to pause the video. Okay, let's take a look. Let me unfreeze for you guys. Quiet, please. Try to follow the work. So I distributed both sides first. I hope you did. And then I went and added like terms. So that's a 7n minus 6 on the left and a negative 25 plus 12n on the right. Now, you can get away without adding the like terms, but that is by far the best way to go. Question Chloe. I don't know. It's an 8. All right? Much better. Hence, no wonder my answer was different from yours. Okay, good. All right, we'll have to fix it all the way through now. All right, so at this point, I decided to go right? Add a negative 7n to both sides. And now I have negative 6 equals negative 25 plus n. Sweet. Now to finish, I'll just move the negative 25. And I'll get 19 equals n. And that is the solution. How many got that correct? All right, great job. Hey, here's the point. Let's count how many things we had to do. All right, you ready? Here we go. 1, 2, 3, 4. We had to add like terms 5, add like terms 6, choose a side 7, move it 8, get this after you move it 9, move that 10, and get that 11. You got to go 11 for 11. Otherwise, you'll get the problem wrong. That's why math can be challenging. You could know what to do and make a mistake along the way. So if it's a mistake, then, hey, let's get better at not making mistakes. If it's we don't understand, that you got to work on. All right, you got your homework, and I'll leave it with you. You got a good 5 minutes, so let's get started.